cases, the average number of widgets that are defected is about 5, with standard deviation of 1.8, and we have a normal distribution.
Stop, Brian.
So, always start with the picture. Always start with the picture. Many people should be able to do A and B on their own. I'm going to model it up here. I'm going to not say too much to give the people who are doing it on their own an opportunity to attempt it. And if you need some support, we can always look up here. And it's saying on A, less than 3 defective widgets are made. So.
In the video, you did not say how to put that in there. I had to go through every operation on the calculator and look for it.
You could have just read me.
Don't care.
Please verify that this is what you're getting for part A. Please verify you get this on part A. And don't just copy down, actually go through the mechanics and make sure you can do this. So we're doing model problem of part A, Shinli, which is a review of what we did. You can leave it there. I'll come right to it. And which is a review of what we did on Tuesday. Thank you. And I'm going to model B up here too. We should be able to finish A and B within about 3 to 4 minutes.
Wait, B?
A and B, both doable using what we already know.
I kind of know.
Remember, always the picture to start.
Do we have to draw the picture?
Yes.
Like, is it going to take points off?
Yes.
Because it's, I don't know. Oh, I beat you.
All right, so here are A and B. I'll give you guys about another minute to catch up. Ensure that you are getting this. If you're not, please ask. You're confused on the picture, please ask. Important to. And so those who are good, begin reading through part C, and that's where I'm going to go here next. That's going to be the new piece. So begin reading through part C. And I'm going to give you a hint. You're going to want to draw the picture again for C. You're going to want to get the picture for C. So Alex, if I move over here to this board, is it going to catch it properly? Should we move it over here?
Yeah.
Should we move it here? Yeah. Keep it on. Eddie Paul? Is this good? Can one of y'all check?
I found my error.
Is it still good? Is it getting me here? Hey Alex, can you check this out? Make sure it's working. All right, so let's move to 1C.
Can you see the board? No, right?
Back it up.
Can you see the board?
Now we're good?
Yeah.
Because some people are going to need to watch. Okay, so on 1C, 1C it says what? How many defective widgets make up the 60th percentile? Now, if we remember back to Unit 1, we talked about percentile. And percentile, you might want to write this down, percentile is the number below which, blank percent of the data is. So the 60th percentile means find the number where 60% of the people are behind it. 90th percentile means find the number where 90% of the people are behind. So if you're in the 90th percentile on a test, that means 90% of people did worse than you. You did the top 10%. So percentile is, if you're in the, if your score was the 20th percentile, that means what? 20% of people did worse, 80% of people did equal or better. So let's apply this now to the graph. So if we think about this, they're saying how many widgets make up the 60th percentile. So let's go ahead and draw our picture. On this axis we have defective widgets coming up, coming down. So, I did. Thank you. Not as bad as Mrs. William circle today in class. You didn't see that? It's on tape though, so it's up for posterity. All right. So we know that the mean is still going to be 5. And I want to know what is the number where 60% are lower. So we know already that how much data... Stuff it here. How much data is here? It's got to be 50%. 50% is below the, remember this is the median and the mean and the mode. It's all three. So here's 50% of the data. So if we want to find the number where 60% is below, that number has to be somewhere over here. It has to be somewhere on this side because I want 60% of the data below it. Here, 50% is below, so I need to go a little bit more so that 60% is below. If the picture doesn't make sense, you need to stop me now. Shamara? Right, because this is the mean and the median. So we need to be a little bit above the median. So I need to find what is this number where all of this area in purple is equal to 0.6. That's what I want to know.
How do you know how much to block off to add?
I don't. I'm just guessing. 60%? 60th percentile? 60% is 0.6?
Oh, and then this will be the half.
Yeah. Okay. Now, so we need to find this number. We need some way to find this number. And here's where we're going to use those. Hey, guys, we need to stay focused. People are going off track here. Need to stay focused. Here's where we're going to use the table. So go ahead and get this table that we gave out. The table you picked up.
You know, in the comments,
I know.
what is this?
Okay. Right, hey guys, so this is going to take people to actually listen so they understand this. The table gives you different z-scores. Z-scores, as we know, tells us the number of standard deviations above the mean, or if it's negative, the number of standard deviations below the mean. Turn with me to page 5, the page that is labeled number 5. Please turn to page 5 with me. And notice, folks, please notice. If you look on the table, move your finger to where it says 0.6026. Did everybody see this? This is on line 1, 2, 3. 0.6026. Line 3 of page 5. Please be on page 5. Look at inside. There's a lot of numbers. You want to move your finger to 0.6026. Put your finger or pencil or some kind of mark there, please. What that is saying is the following. That is saying that at that point, at that z-score, 60% of the data is below that z-score. Okay, what is the z-score? Well, if you keep your finger there, scroll left to with your finger. Scroll left, you get 0.2. And scroll up, you get 0.06. So what that is saying is that if you have a z-score of 0.26, what does that mean? That means 0.26 standard deviations above the mean. That means over here somewhere. Hold on. Give me 1 minute, folks. Give me 1 minute. 0.26 is the z-score we got. This is saying if you are 0.26 standard deviations above the mean, then 60% of the data is back here. Always. For any normal distribution, if the z-score is 0.26, 60% of the data is over here. Now, before I go through the next step, I want to see, are there questions on where this came from? Please ask. Let's start with Tamar. Yes. Yes. Okay. So, we're on page 5. Is it clear why I want to get the 0.6? Is that clear? Okay. So if you move your finger, do you see where it says 0.6026? So if I were to go one space left, that would be too little, because that's 0.59. That's too low. Yeah. Hold on. Shh, you guys, we need to take this very slowly, because this is going to be a skill we use the whole year. So tell it, take it slow. Because I'm in the 60th percentile, so I want 0.6 of the data back here. So the number that is closest to 0.60. Does that work so far? Okay, so then I'm going to take my finger and go left, and I get the 0.2. And then I go up, and I get the 0.06. So that 0.6026 is in row 0.2 and column 0.06. So that's how we got the 0.206, so 0.26. You add it. I mean, it's really more like tenths place is the row, hundredths place is the column. Okay, let's get the next question on this piece. No. Hold on. So, but are there more questions on where we get this? Okay, now this is the z-score we want. This is the score that says what? Remember, z-score is this many standard deviations above the mean is where we want to be. So this equals, remember the formula for z-score? X minus mean over standard deviation. We know mean, right? We know mean, we know standard deviation. Let's find x. Those who have already done it, great.
Over 0.6. What is standard deviation?
So 0.26 equals x minus 5 over, what is the
1.8.
1.8. So we're going to cross multiply, then we're going to add 5. I hope people get 7.322. Earlier? No? 5.468, excuse me. Oh, I'm on my wrong notes. I'm looking at the wrong notes page. I apologize, guys. So yeah, you multiply by 1.8, multiply by 1.8. Hold on. Guys, we have some questions.
Why are you
Khadija.
using 0.26 if you're working on? Aren't you doing part C?
Right, so 0.26 is the z-score. You see how we went through the table?
You just meant on this
Yeah.
table.
Yeah. Okay. And then we can simplify this. We get x equals 5.468. So what that means is if I did on the calculator, if I did this, and here's the real check. Let's see how whether people actually have internalized this. What should this give me on the calculator? No, hold on. You haven't even seen what I put up there. What should this give me on the calculator?
No, that should give you
Yes. Why, Shunli? Why is it 0.4?
Because it's above